Hello, welcome to the 5.3 day 2. Uh, Today we're going to learn about the composite property for tangent. And we're also going to, that's going to be pretty quick, and then after that, then we just do a bunch of problems dealing with our properties. So the first thing we're going to deal with is we have the tangent of a minus b. So we want to see what this is going to reduce to. Tangent of a minus b is the same thing as sine over cosine of a minus b. Now, both of these we can expand to get sine a cosine a minus cosine a sine b over cosine a cosine b plus sine a sine b. So once we had sine over cosine, we just expand both of those. And now is where the trick comes in proving this. What we actually do is we divide out cosine A, cosine B from both the numerator and denominator. But so the trick is that there's not a cosine A, cosine B in either of them except for in this section. So if I take cosine A, cosine B out of this section, it, out of the top, so this is just the numerator that I've uncovered. Uh, so this numerator, if I take out a cosine A, cosine B, it's like I'm dividing by cosine, cosine B, cosine A, cosine B from both sections. And if I do that from the denominator, I do the same thing. So it'll look like this. All right. And so now what we can do is simplify what we can. Cosine B over cosine B cancels out. Cosine A over cosine A cancels out. And cosine A and cosine B cancel out to be a 1. And nothing really cancels out here. So this is going to be uh, sine over cosine, which is tangent of A, minus sine B over cosine of B, which is tangent of B. Oh, and these cancel out on the outside. And then over here we have 1 minus sine over cosine is tangent of A, sine over cosine is tangent of B. So this is going to reduce to that, which tangent of A minus tangent of B over 1 plus tangent of A tangent of B. Now, and that's, we all started with tangent of A minus B. Oh, I can't spell tangent. A minus B. All right, now the next property for tangent, you can derive the same way. It's tangent of A plus B. That's tangent of A plus tangent of B over 1 minus tangent A tangent B. Proof is exactly the same, but we're dealing with addition sign rather than subtraction. All right. Now for the next, so that's a quick lesson on what we learned, what we're learning. Now we're just going to use the composite argument properties to rewrite the left side of one function to solve it generally for the general solution, and then we want to find particular solutions. So if I take a look at this, uh, sine theta cosine 35 plus cosine theta sine 35. What I do is I want to take this and reduce it, so I just have one trigonometric function. We can't solve this if we have a sine and a cosine, but if we consider this an a and a b, this is the same thing as our sine of a plus b, which is theta plus 35. So this whole left side is reduced to sine of theta plus 35 is equal to 1/2. So then to solve this from here, I take the arc cosine of both sides, or arc sine, and the arc sine is the inverse sine plus 360n, and then 180 minus the inverse sine, 1/2 plus 360n. So the inverse sine of 1/2, 1 over 2, that's at 30 degrees. And then 180 minus 30 degrees is 150. So now I subtract 35 from both sides to get theta equals -5 plus 360n. And if we subtract 35 on both sides, theta is going to be 115 plus 360n. So if I'm looking for the values of theta between 0 and 360, it'll just be 115, and -5 doesn't work, but if I add 360, that'll be 355. So these are the particular solutions between 0 and 360, and these are your general solutions. All right, try this one on your own and see if you can get the correct answer. Now this is cosine, cosine, sine, sine, so this is a cosine of 3x minus x equals -1. 3x minus x is going to be 2x. Now I take the arc cosine of both sides, which the arc cosine is just plus or minus the inverse cosine plus 2 pi n. Notice how we're in radians with the x. Now if cosine is the x value, where is the x value going to be -1? That's over here in the unit circle. And so cosine is -1 at pi. So this is going to be 2x equals plus or minus pi plus 2 pi n. Now if I divide by 2, this is going to be plus or minus pi over 2 plus pi n. So that's my general solution, and my values are going to be pi over 2. If I add pi to that, I'll get 3 pi over 2. And that's it. Alright, tangent of theta plus tangent of 27 over 1 minus tangent of theta, tangent of 27. So if we look back at this plus and minus, so that's tangent of A plus B. So this is going to be, this whole thing can be reduced to tangent of theta plus 27. Now notice the difference in from that and this, where it's a minus, so if it's tangent of A minus B, there'll be a subtraction sign here. But if it's plus, there'll be an addition sign. So that's plus, so it's addition. So now I just take the arctan of both sides. And the arctan is going to be the inverse tangent of 1 plus 180n. Remember that tangent, you add 180. And the inverse tangent of 1 is 45 degrees. So if I have theta plus 27 is equal to this, I just subtract 27 from both sides. And theta is going to be 18. So my specific values are going to be 18, 198, so on, all the way around. Alright. Now remember, pause this, see how well you can do on your own. Sine, cosine, cosine, sine. That means it has to be a sine. It's a subtraction sign, so we subtract it. 5x minus 3x is 2x. So we take the arc sine of both sides. So the arc sine is going to be the inverse sine plus 2 pi n. And it's going to be pi minus the inverse sine plus 2 pi n. The inverse sine of 1/2, 1 over 2, that's going to be at 30 degrees, so that's pi over 6. pi minus pi over 6 is going to be 5 pi over 6. If I divide by 2 on both sides, x is going to be pi over 12 plus pi n. And over here it's going to be x is 5 pi over 12 plus pi n. And so my values for x are going to be pi over 12, 5 pi over 12, 11 or 13 pi over 12, and then that would be 17 pi over 12. So those are all the values between 0 and 2 pi. Guess I didn't need that line going through it. Alright, now we're going to go to a different type of problem. We want to find the exact value of cosine of a plus b. If this is a big A, if this is a b, cosine of a plus b, we can't do it by just looking at the information that we have. So we have to expand this to be cosine A, cosine b, minus sine A, sine b. And those we could figure out. The cosine of A, if this is 25 and 24, we know a squared plus 24 squared is going to be 25 squared. So if we take 25 squared, 25 times 25 is 625, I'm pretty sure. And this would be 50, yep, 625. And 24 squared is going to be 576. So a squared plus 576 is going to be 625. So now if I subtract 576 from both sides, I'm going to get 49. So if a is 49, a is going to be 7. So that's a 7 right there. I should actually write that in red. So that distance is 7. So the cosine of a is going to be 7 over 25. The cosine of b is going to be 15 over 17. And then the sine of a is 24 out of 25. To get the sine of b, I'm going to do this opposite side over the hypotenuse. So I'm going to say a squared plus 15 squared is going to be 17 squared. So a squared plus 225 is going to be 17 squared, which is going to be 289. If I subtract 225 from both sides, I'm going to get 464. So if I square root it, a is going to be 8. So that's going to be 8 over 17. Alright. So if I get rid of my work there, now if I want to find this exact value, I can take 7 times 15 to get 105 over 25 times 16, or 17. Now we could probably do this in our head. There's 4 times 25 is 100, so 4 times 4 is 16, so that's 400. This would be 425. So this other denominator is also going to be 425. 8 times 24, that's going to be 192. So when I subtract these out, 105 minus 192 is going to be 87 over 425, and that is my final answer. So the cosine of a plus b is 87 over 425. Wow, a lot of work. A little bit easier if you had your calculator. Alright, Now, using those same values, the sine of a plus b is the sine of a cosine b plus cosine a sine b. Sine of a is 24 out of 25. The cosine of b is 15 out of 17. The cosine of a is 7 out of 25. Sine of b is 8 out of 17. So now we just multiply them. 25 times 17 we found was 425. 7 times 8 is 56. 24 times 15. That's going to be 360. So 360 plus 56 is going to be 416 over 425. And that is my answer. Alright, now if I want to use my knowledge about 30, 45, 60, and 90 degree angles, how can I find what the cosine of 15 is? Well, what I can do is 45 minus 30 is 15. So this is the same thing as cosine of 45 minus 30, which is cosine 45 cosine 30 plus sine 45 sine 30. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1 over 2. Now when I multiply this out, root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. So this is going to be root 6 plus root 2 over 4. And hopefully, yep, that's what's on the right-hand side. If I want to find the cosine of 75, that's 30 plus 45. So that's cosine 30 cosine 45 minus sine 30 sine 45. So cosine of 30 is root 3 over 2. Cosine 45 is root 2 over 2 minus sine of 30, which is 1/2. Sine of 45 is root 2 over 2. So this is going to be root 6 over 4 minus root 2 over 4. So this is going to be root 6 minus root 2 over 4. Alright, hopefully that made sense. And here is your homework for tonight. Good luck.